Welcome everyone. We looked at what matter is. We said matter is anything that occupies space and has weight. And we looked at examples of matter. Anything that is around you is basically matter. And we saw the three states of matter. So in this presentation, we're going to continue with our discussion of matter. But this time around, we want to focus on what makes up matter. And we did say that matter is made up of small particles that we call atoms. Okay, so we want to look at the nature of these atoms. What is the structure of these atoms? What particles actually make up the atoms? And then we'll look at how atoms relate to what we call elements, how they relate to what we call molecules, and how they relate to what we call compounds, and how they relate to what we call mixtures. That's going to be a very good journey, and I want you to really focus and understand these concepts such that you don't get difficulties going forward. Okay? So we want to look at all those terms. I can assure you they're easy to understand. You don't need to memorize them. Like, for example, let us say, pushing them into your head by force. No, you need to understand them. When you understand them, it's easy for you to explain the concepts. It's easier for you, right? Yeah, so that's what I urge you to do. Okay? So, we want to know these terms: atoms, elements, molecules, compounds, mixtures. That's what we want to know. Okay? So we'll start that journey by looking at atoms. We look at the structure of atoms and see the particles that make up an atom. And there are some calculations that we'll have in this presentation. I can assure you still they're not very hard calculations. Okay, so anything around us that you can touch and that has a mass and occupies space is matter. Okay? But things that we can't touch, for example, your emotions, how you feel, we can't say it's matter because we can't weigh them. We don't have mass. So, no. Okay? But things that you can touch, the cup, the gases, though we can't touch, say this is, but at least we know that gases occupy space and they also have mass. Okay? We have liquids and others. You already know that. That's what matter is. Okay? Now, we are saying that matter is made up of particles. These particles are called atoms. So these atoms, we are calling them the smallest unit of matter that can retain the properties of one element. Now this is what will bring challenges, because I'm defining atoms and then there is another thing called element coming in. Don't worry. Basically, everything that we have is made up of elements, and we have about 118 elements. Okay, those are the elements that we know that exist. Okay, so anything, whether it is this laptop in front of me, whether it is this pen, whether it is the chair, whether it is the cloth, whether it is even your body, okay, we have elements. Our body is made up of elements. Okay, the proteins, the carbohydrates, the vitamins, the minerals, roughage, water, those are all elements. Everything is made up of elements. Okay, so we are saying that since everything is made up of elements, those elements have particles that we call atoms. Okay, have particles that we call atoms. Now, for you to have an element, the atoms have to be the same. Okay, so an example of an element, let us say carbon. Carbon is an element. The atoms within carbon are of the same type. Okay, are of the same type. So we are saying that atoms are the smallest unit of matter that retain the properties of an element. So we are saying you have an element, and that element is made up of atoms. The atoms can be 2, can be 3, can be any number. Okay, these elements, these atoms, have the same properties like element. Is that clear? The same chemical properties like the element. Okay, so atoms are the fundamental building blocks of all matter. Everything, because we say that everything that we have elements in them. Okay, and we have 118 elements. And these elements, each element is made up of a special kind of atoms. Okay, the atom of oxygen is on the same atom for carbon, and we shall look at why. Okay, and so the atom has what we call subatomic particles, or the atom itself also has particles, and those particles are the ones that we refer to as electrons, protons, and neutrons. Okay, so proton, neutrons, and electrons, right? These are the particles within an atom. Now, in the middle or the center of an atom, we have the nucleus. Now, the protons and the neutrons are in the center. That's why the arrow is coming to the center, which is the nucleus here. Clear? Yes. Now, around the nucleus, we have what we call orbitals. Orbitals, you can call them electron shells, or we can call them energy shells. We can call them energy shell level. They have many names, but basically the electrons are not in one place within an atom. They keep moving. So they move following a path that we call the orbitals, that we call the electron energy level. Okay. We can also say that electrons orbit. When we say orbiting, it means they are moving around along the particular shell. Okay? I hope that is quite clear. So still the same emphasis. The center, there is a nucleus. In the nucleus, we have 2 types of particles. We have the protons, we have the neutrons. There are shells, which we call the energy levels. And along those shells, we have electrons moving. They are not static. Okay? That is what we call an atom. So when we ask you about describing the structure of an atom consists of a nucleus, which is surrounded by energy levels. And in the nucleus, we have 2 types of particles, protons and neutrons. Along the energy levels, we have electrons that keep moving, revolving, or orbiting around. Okay? That's clear, right? The energy levels can also be called quantum shells. So energy levels are having many names. Don't be confused. Electron shell, energy levels, quantum shells, orbitals, the same thing. So how do we differentiate between these 3 subatomic particles. We look at their charge. The protons are positively charged, P positively charged, protons positively charged. I think you can read that. Neutrons, they are neutral. Okay, they are neutral. They have no net charge, so their charge is 0. Electrons are negatively charged particles. And in terms of mass, electrons have very low mass, about 1/1836. Okay, 1/. That means it is very, very tiny in comparison to the proton. Okay, and then the proton is relatively larger. It's usually say it is, has a relatively higher mass. So we say it is about 1 atomic unit. The proton is 1 atomic mass unit. And then the neutron also relatively there, 1 atomic unit. That's by mass. So meaning that the electron is one which is the mass is very little. Where they located electrons outside the nucleus in the orbits or the orbitals. The neutrons and protons are found in the nucleus. What will they do? All the reactions that you will be having, most of the reactions will involve transfer of electrons. Okay, so the electrons are very, very, very important in issues. For example, we look at reactions that we call reduction oxidation reactions. You see that there. The protons contribute to the atomic mass and help identify the element identity. Now, this is where we talked about the fact that the atom for carbon may not be the same the same atom like that of oxygen. Remember that statement? What's the difference? The difference is in the number of protons. The number of protons is not the same. Actually, for all elements, their number of protons are not the same. You not find an element or two elements. You not find 2 elements that have the same number of protons. Never. Okay, so for example, when you say the atom has proton number 12, it will be only one element that has that number of protons. Okay, and then the neutrons contribute to what you call the atomic mass. We shall look at what that means. And then stability. Electrons are stable in most situations. Similarly, you have protons stable in the nucleus, and then you can also have the neutron being unstable outside the nucleus. And this is where we talk about radioactivity, but this is not a topic that we shall cover in the next 1 or 2 years, perhaps in senior 3 or senior 4. That's when you can look at that topic there. Okay, so we move forward. So we already know that the atom consists of a nucleus and then the shells with different particles, the neutrons and protons in the center, and the electrons moving around in the energy levels. And we have also seen that the electrons are negatively charged, protons positively charged, neutrons are neutral. What is the relationship between these? Is there a formula that tells us the relationship between the number of these particles. Yes, we have that formula. So what is that formula? That formula is basically here. And this is simple formula that you need to know. Okay? So, the number of neutrons is represented by n, capital N. Okay, and then the number. Okay, let me first actually use this side here. Before I move to that side, let's first look at this. The number of protons present in an atom is what you call atomic number. Atomic number. So if they say the atomic number for this element is, let us say, 10, just know that they are saying that the number of protons in that element is 10. That's what they mean. So number of protons is what we call the atomic number. And then another statement that you need to know is that the number of electrons in an atom, especially for a neutral atom, the atom that does not have any charge, that number is equal to the number of electrons is equal to number of protons. Number of electrons is equal to number of protons. So let's also introduce another term. We say that we have 118 elements. Those 118 elements can be represented in a table. That table, we call it the periodic table. Periodic table. The periodic table. So the periodic table has all these elements and all the elements that we know about. So for each element, we have what you call a chemical symbol. A chemical symbol is, for example, here is Be. This is the chemical symbol. What this means is that it can be one letter or two letters that represent an element. Okay? So, for example, this one is actually beryllium. It's the element called beryllium. But let's go with the simple one. Hydrogen. The symbol is capital H. The chemical symbol is for hydrogen is capital H. So, in that periodic table, for each element, we have the atomic number, which is the number of protons. It's usually written up here. It's number of protons. So it's number of protons. And then down here, that is what we call the atomic mass. The atomic mass, which is the number of protons and neutrons. Protons and neutrons. That's what we call atomic mass. Okay? So, when you add the number of neutrons and the protons, you get the atomic mass. This is a formula, meaning that if you have two of these, if you have the number of neutrons here, you have the number here. If you have the number here, okay, you can get, if you have the number of neutrons and you have the number of protons, you can get the atomic mass. If you have the number of protons and you have the number of the atomic mass, you can get the neutrons. That's what it means. Okay, so this formula, please just note it, that the number of neutrons plus the number of protons is equal to atomic mass. Just know that formula. Having looked at atoms, now we can look at what we call molecules. This follows the statement that said that if you have groups of atoms that are the same, and then you will have an element, and that's why we have more than one. That's why we have 118 elements. We are saying that atoms can exist alone, but they can also combine to form what we call molecules. That combination can be with atoms that of the same kind, or it can be with atoms that are not of the same kind, but all result in what we call molecules. So, for example, here you have illustrations of how water, which is written as H2, that's water, right? And then we have oxygen, O2. Okay? So what do you notice here? What this formula communicate is the fact that you have atoms. Okay, you have atoms that are combining. Okay, so here, this is basically to show you something like closer. This is not the reality of how oxygen atoms combine. Okay, this may not be a good picture to represent that. Basically, what this is showing you is that you have one oxygen atom combining with another oxygen atom. And the combination is through the linkage between atoms, is what we call bonds. We call them chemical bonds. So in this case, we have two chemical bonds. So you have one atom here, another atom here. Okay, so oxygen exists as what we call diatomic molecule, meaning that it has two atoms, always exists as two atoms. Okay, so that is what we are saying, that when you have atoms combining chemically, you form what we call a molecule. The same case also applies with what we see here. This is a representation of water. Okay, so you have an oxygen atom that combines with the two other hydrogen atoms to form a molecule of water. So one hydrogen is here, another hydrogen is here. Okay, so you have a molecule of water. Okay, so you can say that oxygen is not the same as hydrogen. So for you to have a molecule, you don't necessarily need to have atoms of the same kind. Okay, so you can still have atoms of the same type or of different types combining chemically through chemical bonds, and then we have what we call a molecule. Okay, we move elements. I've been referring to this number frequently, basically to show you that everything that we have, whether it is this shirt I'm putting on, whether it is a necklace, whether it is this phone, whether it is this recorder here, okay, anything, things that we use in our daily lives, these things are made from what we call elements. Okay, even the food that we eat actually contains elements. We have already stated that. So, what is an element? An element is the pure substance that cannot be broken into another substance by chemical means. So you have the element hydrogen. You can't break hydrogen to form another element. Carbon, you can't. Okay, it remains that. Okay, so it is the purest. These are pure substances that cannot be broken down further by any chemical means. We shall look at what chemical means are. Okay, or what physical means are. Okay, so each element has a unique atomic number, the number of protons in the nucleus of an atom, is what we call atomic number. And we say that it is the atomic number that makes the element different from others. Okay, each element has its own atomic number. So we can say that the number of protons helps us in identifying which element we are talking about. Okay? And then we have what you call a periodic table. So for all our elements, they are written in a table that we call the periodic table. And we saw how the periodic table has, for example, in this diagram, in this picture that you have here, it's just a part of the periodic table. Of course, we'll have a full lesson on what a periodic table is, but for now, just know that all elements are represented on a periodic table. That means that for each element, we have the name of the element. If it is sodium, we have the name sodium. We have the symbol for sodium, which is basically one or two letters that represent the element. Okay, so everyone knows that, for example, if you write capital N with a small a, everyone will know, if they have studied chemistry, they will basically know that that is sodium we're talking about. Okay, so this is the symbol for sodium. Okay, it will also contain what we call the atomic mass, which is the number of protons and neutrons in the of one atom. Okay, and then we have, it also has the atomic number, which is basically the number of protons in the nucleus of one atom. Okay, so these elements in the periodic table, as we shall see later on, they are 118, and they are categorized based on a number of things, based on the number of shells that they have, and also based on the number of electrons that they have in the outermost shell. We shall look at that. Okay, so here it's just the periodic table. What are we talking about here? So this is a complete periodic table with the different elements and their symbols, their atomic mass, and their atomic number. Okay, and their name. Okay, so we have hydrogen, lithium, sodium, potassium, many other elements that you will get to learn later on. Okay, so the other concept that we want to know is what you call compounds. So when you have molecules, combining chemically, we form what we call a compound. That combination follows a fixed ratio. Here. So let me just use the example of water. For you to have water, you have hydrogen So, okay, disregard this. So you have just a minute, huh? Just a minute. Okay, so let's look at what we call compounds. So when we have two different molecules combining, not even molecules, compounds are formed when you have groups of atoms that are not of the same type combining chemically through a fixed ratio. Then you have what we call a compound. So, for example, you have water, which is H2O. This is the formula for water. Okay? Water therefore means that you have atoms of hydrogen and the atom for water combining. So that means that water is a compound. What is very important to note is that this combination follows a fixed ratio. This is to say that they have to have two hydrogen atoms combining with one oxygen atom, okay, to form a water molecule, which is basically a compound. Okay, so we are saying that compounds are a specific type of molecular type formed when two or more different types of atoms combine, of course chemically, to form what we call a compound. This combination happens at a fixed ratio, just like what I've just illustrated. Okay, so if you have you can have more than two groups, could be three groups of atoms combining to form a compound. For example, here we have, this is water, of course, that you know, and then this is glucose. With glucose, you have hydrogen, you have carbon, you have oxygen. Okay, that's what you have, three types of atoms to form glucose, which is a compound, an organic compound. You will learn that in subsequent sessions. So basically, in summary, about the concepts of atoms, elements, and molecules and compounds, we are saying that an atom is the smallest indivisible electronically neutral particle of an element that can take part in a chemical reaction. So, as we shall talk about chemical reactions, remember we said that the electrons are part, right? Now we are also emphasizing that the atoms are part, because electrons are basically a part of atoms. Okay, so the transfer of atoms or groups of atoms is basically what constitutes what you call chemical reactions, and we shall look at that subsequently. Okay, if you were to relate that to what we started with, we said that matter is made up of particles, small particles called atoms, and we describe the structure of atoms, which you remember very well. Okay, and then we are saying that if you have atoms of the same kind, then you have what we call elements, and we have several elements, and we are saying that the element and the atom are having the same characteristics, same chemical characteristics. Okay, and then a molecule is when you have two or more atoms that are chemically bonded. Okay, so you can have water molecule, you can have hydrogen, H2. This is a molecule. So it has hydrogen atom and another hydrogen atom, the same molecule. Water, you have oxygen and then two hydrogen atoms. These are also molecules. Okay. The difference with the compound is that you have them combining at a fixed ratio. Okay, here we are saying that a compound is a type of molecule formed when two or more different types of atoms combine together at a fixed ratio. Okay, so that's why you have water, carbon dioxide, and also methane. This slide will need to be edited. Okay, this slide will need to be edited. So let's look at a substance. Okay, because these are words that we shall use a lot. When you heat a substance, when you heat a chemical, so these are words that you'll be using a lot in your chemistry classes. A substance, let's just understand it in a way that, for example, this is sugar. Okay, this image here shows sugar. Do you see anything different? Everything is the same, uniform. It's the same kind of thing. If you have the same kind of thing, then that is a pure substance. Okay, it's a pure substance. Okay, so a substance can refer to a particular type of matter with a fixed composition and set properties. Okay, this therefore means that the particles that make up that substance are of the same kind. Okay, the same type. They have the same size, the same consistency, and okay, that's what we call substance. Okay, and then if you have two substances mixed together, for example, you can have sugar mixed with water, you get what you call a mixture. This mixing is physical combination. It's not a chemical combination, something that you need to note here. Okay, there are no bonds yet. Yes, you get one substance, mix it with the other. It could be sand and flour, that's a mixture. It could be alcohol in water, that is a mixture. Okay, so we have two types of mixtures that can be formed. You have what you call heterogeneous mixtures. This one, you can see that the two components of this mixture have not mixed well. Okay, so you can say this is water, then this is oil. Okay, that is a heterogeneous mixture. So we can call that immiscible mixture and miscible mixtures. And then we have those that can easily mix and you form a solution. And you can't say this is the water, this is the other substance. No, it completely mixes. So if you have sugar and mix it with water, the sugar dissolves in water and you can't notice where the sugar is and where the water is. Okay? That is what we call homogeneous mixtures. Okay? So therefore, chemistry is concerned with the study of matter, and matter can be looked at as substances, the same kind of thing, and then where you have different kinds of things as mixtures that are made, physically combined, and then with, for example, the sugar that we talked about. Within sugar itself, which is glucose, sugar is basically glucose. You have carbon, hydrogen, and oxygen, right? If you remember that. Those are elements. The carbon, hydrogen, and oxygen, those are elements. Okay? But the glucose that you have, that's the sugar, is a compound. Here, glucose is a compound. Here, you have oil and water, sand and water, heterogeneous, and then homogeneous solutions. You have sugar and water mixed completely. So in chemistry, these are basically things that we look at. Okay, so that marks the end of this presentation where we have looked at atoms, the particles that are found in atoms. We looked at a little bit about elements, molecules, and compounds. What is very key to note is that all matter contain particles that we call atoms. These atoms have particles in them. We have the electrons, which are always moving around in the shells. We have the protons and neutrons, which are found inside the nucleus of an atom. We said that the number of protons is what we call atomic number. It is what makes elements different. You cannot have two elements with the same atomic number. We can have a relationship between the atomic mass, which is the number of protons, and number of neutrons. If you add the two, you get what we call the atomic mass. Therefore, if you have two of them, you can find the other. And we use the formula that atomic mass is equal to the number of protons plus the number of neutrons. Okay? And then we said that atoms can exist alone, but they can also combine with others. Atoms can combine with similar atoms. That means atoms with the same atomic number to form what you call molecules. Or atoms can combine with atoms of different types. For example, you have hydrogen atoms combining with oxygen to form water. Water becomes a molecule. Okay? Becomes a molecule with H2O. But then we introduced in the term called compounds. Okay? We are saying that when you have different atoms combining chemically in a fixed ratio, you have what we call a compound. And therefore, water is actually a compound. Carbon dioxide is a compound. Methane is a compound. Because we have different groups of atoms that are combining at a fixed rate to form those compounds. And then we looked at what we call substance. We say that we shall use that word a lot in chemistry. Okay? When we talk about substance, we are meaning something that is, the constituents are the same. Okay? The nature of the molecules that form this substance are the same. So, for example, if you see sugar, we say sugar is a substance, something that is actually, the molecules are the same, uniform. Okay, that consistency.
You don't have other things added to it. But when you have two substances added together, we have flour added with sugar, then you have what you call a mixture. This happens physically. Someone adds and then they have a mixture. And these mixtures can be heterogeneous or homogeneous, depending on the extent to which they mix with one another. You can have heterogeneous, for example, you have the sand and water. When you mix, the sand will not dissolve in the water. So that is a heterogeneous mixture. When we talk about homogeneous mixture, we're talking about substances that, when combined physically, completely dissolve into to form a solution. Okay, to form a solution. So it becomes homogeneous. And we can use the word miscible liquids and then immiscible liquids or immiscible mixtures. Okay, so that has been